A photoelectric surface is illuminated successively by monochromatic light of wavelength lambda and lambda by 2. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that in the first case, the work function of the surface of the material is where h is equal to Planck's constant and c is equal to speed of light. Okay. Now, according to the Einstein photoelectric equation, the maximum kinetic energy of the emitted photoelectrons in the first case, that is, we can write it as K max in the first case, that is 1, which is equal to hc by lambda minus phi naught, where phi naught denotes the work function of the material surface. And in the second case, that is K max 2, I can write this one as 2 times of hc divided by lambda minus phi naught. Then the given, there is a K max, that is the second case, K max 2 is equal to 3 times of K max 1. Then, which is nothing but 2 times of hc divided by lambda minus phi naught is equal to 3 times of hc divided by lambda minus phi naught. Okay, this is a K max 1 here. Then, further simplified, we get the value, that is 2 times of hc divided by lambda minus phi naught is equal to 3 hc by lambda minus 3 phi naught. Then 3 phi naught minus phi naught is equal to 3 hc by lambda minus 2 hc by lambda. We get the answer. There's a 2 phi naught is equal to hc by lambda, or we can write this one as phi naught is equal to hc by 2 lambda. Then we can see this one, that is phi naught is equal to hc by 2 lambda. hc by 2 lambda, that is option B is our right answer.